Hello everyone. Welcome to the 44th webinar in 12D's training webinar series. My name is Lisa Stewart and I'm the Marketing and Communications Coordinator here at 12D Solutions. 12D's training webinars showcase common industry challenges, taking a close look at industry best practices and how these can be implemented using 12D products. The aim of these webinars is to upskill 12D users and broaden their understanding of the capabilities of 12D products. We run these webinars regularly and record them for posting through our website and on YouTube. The first 43 webinars from this training series, as well as the webinars from our Industry Solutions series, are available on our YouTube channels if you missed those. While we wait for everyone to finish joining and get comfortable, I'll launch a polling question. You'll have about 30 seconds to answer about how you currently model culverts in 12D Model, and then I'll show the results. Okay, it looks like we've got a bit of a mixture of attendees today. A slight win for super alignment strings, but I'm sure Owen will have a lot of tips for everyone. Okay, let's get started. During this live presentation, you'll be able to type your questions along the way. We'll put some instructions on the screen. We'll answer as many as possible of those throughout the webinar, and at the end, I'll read out some of your questions to the presenter for his insights if there's time. Today's webinar, Precise Culvert Length and Location with Drainage Strings, will be presented by Owen Thornton, who has been writing software for 12D Solutions since 2003. Owen has 17 years of professional experience in the civil and mining industries. He's the original author of 12D's Drainage Network Editor and the Drainage Analysis module, and is a 12D specialist in drainage, utilities, plot parameter files, survey conformance, volumetrics, and system setup. Owen has recent consulting experience using 12D Model on a variety of large projects. These days, Owen also delivers regular 12D training courses in drainage design and macro writing. Today's webinar will demonstrate how to align and grade a drainage string culvert with precision in both the horizontal and vertical to best suit the batter slope of the road it crosses and to allow for an integer number of prefabricated pipe and box lengths. Plan and long section plots of the culvert will be produced, and the culvert and its head walls will also be converted to trimeshes for use beyond hydraulic modelling, for example in road design and BIM. Over to you, Owen.
Hello everyone. As Lisa suggested, today we're talking about culverts and specifically modelling culverts in 12D model using drainage strings. Now this webinar is not going to cover anything about hydraulics or hydrology. We're going to imagine that that's not our problem today. Our problem today is to model a culvert for construction purposes so that it potentially could go and be built or be used as part of another part of the design process in the road design or something like that. Okay, so we're not going to scare you with any terms like catchments or times of concentration or hydrographs or anything like that. It's really just going to be about getting your culvert in the right spot so it can be built. So there's two main groups of people, I imagine, who might find this thing useful, and that is you might be a road designer who just needs to model a culvert underneath the road for the purposes of your road design. You may already know what the culvert size is and you just need to model it accurately. Or conversely, you may be a drainage designer who knows an awful lot about culvert design in terms of the hydraulics and the hydrology, but you may not necessarily know how to model a culvert accurately in terms of the geometry for construction inside 12D. So in both cases I would still recommend drainage strings. You can see on the screen here I've got a plan view of a drainage string culvert with 3 barrels there. That is a single drainage string there. One of the big benefits you have with using drainage strings is you can model multi-barrel culverts very easily. The other big benefit is that the drainage string in 12D is the only string in 12D where you can model wall thickness for whether it's a box culvert or a pipe culvert, and also on the nodes as well you can apply wall thickness if you need it. There are other benefits as well. I'll talk a bit more about some of the other images you can see there, the long section plot and the perspective view. But there are other benefits on why you would use drainage strings as opposed to any other string in 12D for modelling culverts. The other benefits are the grading and the pipe cover or culvert cover underneath the road are parametric values, and they're relative to your finished surface tin. So one is not independent of the other. You can relate your culvert levels to your tin levels. Also, we have a tool to set the culvert length easily and precisely in terms of an integer number of prefabricated links once you've got the levels of your culvert established. Also, using drainage strings, because everything's stored as attributes on the drainage string, whether it's a pit attribute or a pipe attribute or a string attribute or a model attribute, we've got full access to all of those attributes, and schedules of multiple culverts are simple to produce. So you would definitely want to use drainage strings for this, even if your job was simply to produce a culvert schedule. Drainage strings are the easiest way to get data out compared with any other string in 12D. Culverts and headwalls can easily be converted to trimeshes as well. I'll talk especially on the headwalls part. I'll have something to show at towards the end of this webinar. And I'll show a little bit about the specialised drainage plan and long section plots, which you can use on drainage strings, of course, which are ideal for producing drawings of culverts as well as any other bit of drainage infrastructure. And of course, not forgetting that these drainage strings can also be used for hydrological and hydraulic analysis as well. And again, the drainage string is the only thing that can be used for that in 12D model. Just a little note before I go on to, I keep mentioning these things called drainage strings. Version 14 is going to be released shortly after our conference in July this year. And from version 14 onwards, the drainage string will be renamed as the water services string. Also, we're progressively planning to revise our software, and the terms pits and pipes will start being referred to as nodes and links instead. And this is mainly because the old drainage string has been developed to such a point now where it's useful in so many more different applications than just drainage and sewer. It's also for water distribution, but it might not even be a water service at all. It might be a any kind of wet or dry, gravity or non-gravity service. The drainage string and what will become the water services string can be used for it. Okay, so I'm going to be showing you how to, from scratch, lay down a drainage string to model a culvert, and there's a few little tips that I've written down here for the best way to do that. I recommend the use of the drainage string editor only sparingly, just to place your nodes or headwalls in this case in plan, and not really use it for much else. For everything else, I'm pretty much going to use the drainage network editor because it's a one-stop shop for just about everything else. And the last little note there is to create or update your drainage model by reading in a drainage model template. Now this can save you a little bit of time because the drainage network editor does have a lot of settings, and if you've already done this step or this job of modeling culverts in a previous project or something like that, you can save that drainage model that you developed away as a thing called a drainage model template. And that can be used as the best way to create a new drainage model in your new project. And it will save you a bit of time in presetting some of the model attributes so that you don't have to figure out how to configure the drainage network editor every time you create a new drainage model. Okay, so I'm going to demonstrate these first few steps now. I've got a 12D project here, and what we're seeing here on the screen is on the left-hand side here, I've got a view called DR for drainage, which is set up for doing drainage design in. On the right-hand side, I've got a little fragment of road design with some kind of waterway running underneath. On the right-hand side, or the upstream side, it's flowing from right to left there. I've got something more like an engineered swale in the design, in the survey, and that's flowing underneath the road, and it's becoming more of a natural creek on the downstream side. And I've got this little fragment of road there under which we wish to design a culvert. Now here's a cross-section of the road at this culvert location, and I've also got a couple of crossing services that I need to avoid too. The cyan one there is supposedly a water main, and the brown one down here is a sewer main. Okay, so the first step is to create a drainage string. So I'm going to bring up my drainage menu now, and that is under Design, Drainage Sewer. Hover right on Drainage Sewer and click on Drainage in square brackets, and I can just drag that off to the right there, somewhere convenient. I do also have my drainage toolbar up as well. I could use that one as well, but for now I'm just going to go to Drainage, Create, Create. And this pops up the dialog called Create Drainage Strings to allow me to create a new drainage string. And I'm going to call this particular culvert TP1. It's a part of my transverse drainage system, so T for transverse, P for proposed, and it's the first string, so I'm going to call it Transverse Proposed 1, or TP1. And I'm going to put it in a model called DR for drainage, and I'm going to add it to my pre-existing drainage view. So capital DR, comma, capital DR, model name, comma, view name. I'm going to choose a different color than cyan for my drainage string. Cyan tends to get used for hydraulic grade lines and other things, but I tend to prefer one of the plot colors that we have in our colors.4d. It begins with the letters PPF, so I can type in PPF and hit Control D, and it just gives me a list of all the PPF colors, and the one I want is called PPF Design Drainage. And it's a nice bright orange color, and when you plot it out it goes to a suitably weighted black pen on a drawing. The flow direction, you do have an option to go same as or opposite to the string direction. Most people in stormwater go same as, but some people do mix and match a little bit, especially with culverts. But today I'm going to stick with the normal convention, which is same as string convention. It is an important concept, this idea of the flow direction as a setting on a drainage string. It largely depends which way you want your drainage string to look in a section view or a section plot, whether you want the fall from left to right or from right to left. That's the main thing it determines, and it's up to you which convention you wish to adopt. At this time too, I can also allocate two different tins that will be linked to my drainage string, one for the finished surface, which I've got a super tin here of my survey and design tins, and my natural surface tin, which is just my survey tin. I'm not going to bother with connection points, and I'm only going to create one culvert for this simple webinar today. It's just a simple demonstration of how to do this. I'll go ahead and hit the Create button, and this brings up the drainage string editor. And again, I'm only using this drainage string editor sparingly, and in fact I'm only going to use a single option of it under the Edits menu to add append manhole, which will in version 14 hopefully become add append node. So I select this option and it immediately pops up my all drainage defaults menu, and this is going to allow me to, for all of the elements I'm about to create, it doesn't affect anything that may already be in my project, but anything I'm about to create is going to be created with these node defaults and these link defaults, and they happen to be okay for what I'm about to do. You can change them if you want, but for culverts I like to use one of these head wall auto types, whether it's the inlet or the outlet, as a starting point. And in this case I've got a default pipe size of 450 mil with a minimum grade of 0.5% or 1 in 200 and a cover of 600 mil and a pipe class of 3 for my pipe culvert here. Okay, so that will do. I don't really need that. And I now will zoom right in and say, well, I want to use the center line of the upstream swale here as my guiding line, I guess. Now, in this particular instance, it happens to be beautifully perpendicular with my road. In some cases, and most cases, that's the way they build culverts these days. They certainly try to avoid building skew ones if they can because they're more complicated and more expensive. But if your incoming swale wasn't perfectly perpendicular, you can still make your culvert perpendicular to your road if you know what you're doing with your snaps commands. So if I nominate a start point here, now I'm drawing my string from upstream to downstream in the direction of flow. That was the setting I gave it on the creation panel. So I need to pick somewhere on this center line here, and I'm going to pick, normally it's just a little bit upstream, up a little bit up the batter slope, somewhere around about there. I'll choose as my first upstream head wall, or culvert inlet if you like. And I select a node there, and if I wanted to now make this perfectly perpendicular to this road center line, the next step I'm going to do is right click to bring up pickups and do a perpendicular snaps CAD command to my road center line like so. Now wherever I move my mouse, it's asking me to digitize the second point for my drainage string, and wherever I move my mouse, it's dropping perpendicularly onto the road center line. So if I go back and select my first point from my culvert inlet, it's going to drop perpendicularly onto the center line like so. From this point I hit escape to cancel the append, and you know what, I lied just before. I am going to use one extra option under the edits menu. I'm going to go to edits extend and just select the downstream end of my new culvert and just drag it to the other side and somewhere around about there. I'm going to stop a little bit shy of the bottom of the batter slope. Most culverts sort of are roughly look like this in plan. They don't typically extend all the way to the bottom of the batter slope there because there's typically a head wall built in place there that fits, makes the, ties in nicely to the batter slope and gets the apron or the bottom of the head wall fitting snugly with the bottom of the channel at either end. Okay, now that's not been placed in lengthwise with precision. Certainly the alignment of this culvert is now perfectly perpendicular with our road center line, but the length of that culvert we've only just put in very roughly. Okay, but that's all I need to do to get the basic horizontal geometry of my culvert in place, and that's all I'm going to use the string editor for, so I'm going to save and finish now. And for the rest of this first step, I'm going to open up the network editor, and that is from the drainage menu, the third option down, or you can use the drainage toolbar. It's the first icon on the drainage toolbar. And I simply load up the drainage network editor and pick on one of my nodes. First time you use the drainage network editor in a project, you'll often get this little prompt there. If you ever do, my recommendation is typically to just tick on this tick box and say update from drainage.4d. That'll stop that prompt from reoccurring, and that's typically the procedure I want to take. Now, to get us started in the network editor, if you're not familiar at all, what is most important is to get these global and defaults settings all filled away. And you can see there's potentially a lot of settings there to fill in, and I don't want to spend all of the time in this webinar filling in all of these sub-tabs. And this is what I mentioned before, the drainage model template can be a great way to get you started, especially if you know, for instance, if I go to the defaults pits tab, there's these settings there for cover RL and grate RL and set out mode and all of this sort of thing. And you might not necessarily recall off the top of your head the best way to set these when you're designing culverts. Well, if you have a model that you've designed already, perhaps in another project, in a different job, in a different part of the world entirely even, you can save that drainage model away as a drainage model template and apply it to your new model here. And that's what I'm going to do right now. Before I go any further, I'm just going to close this network editor down and go back to my drainage menu under Create. There's an option called Create Read Template. So I'll bring that option up. It's a very simple little panel, looks like this. and I'm going to read a drainage model template into my drainage model called DR using a template file that I've got set up in advance called Culvert model template. Now, if you don't have one in advance, that's okay. After you've set up your drainage model for the first time and got your model the way you want it, you can come back to this panel and write a drainage model template from your drainage model, and effectively all a drainage model template is a 12D archive file, a 12DA file of your drainage model, but without any strings. All it's got is a few hundred model attributes set in there, and they get applied to your drainage model, and they are used by those global and defaults tabs in your network editor, and it can save you a big amount of time. So I'm going to go ahead and hit process there to read that one in, and simply come back into my network editor. Again, I get this prompt, update from drainage.4d. That prompt won't happen anymore now that I've updated that template. But if I go to my global and default settings now, there's a couple of subtle changes there. Notably, if I go to the utility models tab, for instance, it's filled in a road design file for me, and I already had a road design file set up for this drainage model, which allows me to establish a link between my drainage strings in my drainage model and any road strings I want to link it to. And if I was interested, for instance, in establishing a link to my road center line, which you often want to do for culverts, it's a single line in this file is all you need. I'll open this up for you, click on the folder icon and go down to open, and it's a single line in the road design file. It looks like this, just saying, in my road center lines are in a model called alignment. I don't care what the name of the center line is. For each node in my drainage model, please tell me what the nearest alignment string is that is within 50 meters. And that is all I need to do in terms of telling 12D where to find the road center lines. 12D will do the rest for you. Okay. Likewise, on the service clashes file, I've got one that I've already set up through that drainage model template, and I'll open it up. And this one's merely saying here that I've got two crossing services here in two separate models. One's in a model called UT sewer, utility sewer, and one's in a model called utility water. The sewer is down there, you can see in the cross section, or also in the plan here, the brown one. And the water line is the cyan line we can see here in the plan and here in the cross section. And in both cases, I want to ensure that my culvert is at least 300 millimeters away vertically from those two services. So again, I don't need to do anything more than that. 12D now knows about these additional services and will check against those services when we come time to set the levels on it. Okay. Other things you can set up here that I've done in the template were to set the text style on my pit labels. Now I don't think I can see my pit labels yet, but let me just see if I can toggle them on. And you can see I've already turned them off in my view. I'll turn them back on for the moment. And I can see little text labels there saying a tiny little X there. Okay. And the first thing we might want to do, in fact, is run set pit names. And that opens up a sub-panel of the network editor. And again, because I read in that drainage model template, it remembers the way I want to name these. And I go ahead and hit the run button there and back to editor. And I've just assigned two names to each of my nodes, TP1A for the inlet and TP1B for the outlet. And that's my particular naming convention. I like to use the A's and B's for my inlet and outlet head walls. Okay, so far so good. Okay, now I'm just going to save that, and that was the first slide that we just went through that covered the basic use of the drainage string editor and how to read a drainage model template. I've got a little bit more to show with the drainage network editor, of course. We're by no means done. But I'll go over to the next slide now. And here's a sort of a step-by-step listing of the way I would use the drainage network editor. if I was going to now go and set up this culvert for accurate modelling. So I'll go through these steps one by one, and in fact I've already done them a little bit out of order because I've already assigned in step 2 here the node and link names via the Set Bit Names button. What I haven't yet done is set the link and node types via the Pit and Pipe tabs. I also need to set the great RLs, and it is important to set the great RLs before you do much else. Get the great RLs correct, and now what I mean by the great RLs, this is potentially your maximum water level, I guess, and it might, because even though we're not modelling this for hydraulics, it's still an important setting for a culvert. In terms of, you basically need to ensure it's higher than the obvert of your culvert. Otherwise, 12D may consider that an open channel rather than a closed conduit underneath the road. Okay, so the great RL needs to be above the obvert of the culvert. After you've set the great RL, you can go ahead and set whatever dimensions you want on your culvert, whether you want a box culvert or a pipe culvert, how many barrels you want, what size conduits and all of that sort of thing. And then we'll talk a little bit more about the grading. And we reinforce all of the above settings by pressing the Set Pit Details and the Regrade Pipes button. So let me now go and demonstrate that. Okay, I'll start off on the Pit tab. And it's currently, both of my 2 head walls are set with a pit type called Headwall in Auto. Now those auto variants we have in our default drainage.4D, or this is the Brisbane City Council one, but it's the same in the generic drainage.4D that we ship with 12D. They all have these Headwall in and auto and Headwall in and Headwall out auto and Headwall out types in them. The auto variants have the feature of setting a number of different properties of a head wall, but they lock you out of changing them there. And the non-auto variant releases the locks and allows you to change it if you want. So what I tend to do is start off by setting the pit types to the auto one. Now this is my head wall in auto, and I can swap it now to the ordinary head wall in. I'll do the same thing on the downstream end. First of all, I'll set it to a head wall out auto, and then change it to a head wall out. So that's the head wall types, but there's also, of course, the culvert type itself, and for that I need to go back to the culvert inlet. So I'm back on my culvert inlet, and I can move over to the pipe tab now. And here I can set the pipe type and the shape and the size of it. This is on the pipe main tab, and at the top of the pipe tab I can set my pipe type. If I wanted a pipe culvert, I'd choose whatever pipe class I wanted for that. In this case it's set to 3. If I wanted to make that a box culvert, for instance, I'd change it to the BC for box culvert type, and come down into the dimensions area here and say I want a rectangular box, a rectangular culvert I should say. And once you do that, all of the standard box culvert sizes are stored or programmed into that BC type, and you can go and select it from the list there. So if I wanted a something like a 750 by 450 box culvert, and let's say I wanted 2 barrels, and let's say for the sake of argument that I wanted to separate them by a small amount. Normally with twin barrels like that you'd separate them by about 40 mils, I think, so that you can mortar up the gap in between them. And if I went and did that and hit either apply or set pit details, it draws the 2 barrels in for me automatically. And I can look at that in section view or even perspective view. Let's have a look in perspective view now. Here's an overview of my scene, and if I add in my drainage model, and I do need, when you've got translucent tins as I do, you need to make sure the tin is at the front of the view because that's the translucent element. So I'll send that to the front, and I can suddenly see my twin box culverts there, like so. And alternatively I could say, actually no, I'd rather do the cheaper option and go with pipe culverts. So I'll go back to class 3 here, change the shape to circular, and I'll leave that as a 450, but I'll go with 3 barrels and maybe a different separation. Normally you have a wider separation between the multiple barrels of something like 450 for a 450 pipe. It depends, and it does vary from place to place what the different standards are, but I'm going to go with 450 today. Set pit details, and as soon as I do that, I see 3 barrels in the perspective view and 3 barrels, circular barrels, in the plan as well. Okay, so that's got the basic shape of my culvert in place, but let's now have a look at it in section view. I'm just going to drag my plan view up here, and I've got a view prepared below a drainage long section view, it's called, and I'm just going to profile that new culvert that I've just designed. And if I make that exaggerated at about 5 times, say, you can see initially when you lay down a culvert in 12D, it normally makes the culvert too deep because it's trying to maintain your specified pipe cover limit across the whole length of the culvert. And a culvert, or in fact any drainage string that's supposed to daylight or stick out of the ground, is supposed to breach its cover limit at certain points. Otherwise it can't stick out of the ground. So the first thing we need to do is allow this culvert to get a bit higher, and the first thing we do before we can do that even is the best idea. It's not critical that you do this step first, but I would recommend very strongly that you set the grate levels before you go any further here. So I'm going to come to the pit tab on my culvert inlet. Now on the section view the inlet's on the left, even though on the plan it's on the right, because my string direction is in the flow direction. So from left to right is upstream to downstream on the section view. It's the reverse in the plan view. So hopefully that's not too confusing. But one of the things my drainage model template did was it set the default grate RL to manual mode, which means I type in the grate RL that I want. Now I need to ensure that it's at least as high as the culvert obvert, but my culvert obvert's way too low. I'm going to have to lift this whole culvert up higher so it sort of ties in roughly to where these the inverts of my channel upstream and downstream are. If I lift up the culvert too early, it effectively squashes the whole top of the culvert or slices the whole top of the culvert off if my grate levels are inside the barrel of the culvert. And in that way 12D considers it an open channel, which is not what we want. So set the grate levels first. Hydraulically they're the important one. The cover level is not so important, and I normally, and this is entirely optional, but I normally set the cover RL set to the maximum obvert, which sets the cover RL to the top of the pipe, and I set the grate RL manually. Now this culvert is an interesting one. Normally you'd set your grate RL, which is the maximum water level, right up at the top of the road level there, in this case the back of the footpath of this road. But this is a bit of an interesting culvert in that where the water, if the water were to rise up here, looking at the contours, it would actually start to spill around about here, and it would actually not spill onto the road, but spill off to the side here. And that level, looking at the contours, is a fair bit lower than this road level. So it's actually around about level 30.1. So I'm going to type in a grate RL of 30.1 here, and on the downstream side as well, 30.1. And hit set pit details. And that draws the 2 little tick marks indicating the grate level on the section view there at 30.1. And it's now a good time to come and set the pipe inverts. Now to edit the pipe or the culvert, I need to go back to the culvert inlet and edit the pipe downstream of the culvert inlet. So now I can move on to the pipe tab, and I've already set the pipe main settings there. I could, anytime I wanted, just come and set the invert levels and lock them up here, but I'm going to show you how you can do it parametrically as an alternative. But by all means, there's no reason why you couldn't go and either measure or type in an invert level off the screen here, and then tick on the locks there to lock the inverts upstream and downstream, and that's a perfectly valid way of doing it. But I'm going to go over to the pipe design tab now and show you an alternative. Now at the moment, if I say regrade pipes, it just adjusts things a little bit there, but it's still trying to grade things way too deep. What I might do, first thing I normally do is set my grade mode here to minimum grade, and I mainly do that because I'm about to set these to skip cover distances. Now these are distances on the upstream here, skip cover distance upstream, it's the portion of pipe that lies underneath the upstream batter slope, and the downstream one is the length of pipe that lies underneath the downstream batter slope. And what we're telling 12D there is simply ignore the pipe cover underneath the batter slopes, because I'm really only interested in the cover underneath the road there. Okay, so and when you use those skip cover distances, most of the time you'll find that the minimum grade mode there is going to work better than the default, which was minimum depth mode. That's sort of a minor issue there, but something I think worth noting. But to get the skip cover distances, the way I do it is I use the measure icon here, and I go measure, point to point, length, and I'll measure from the very upstream end of the culvert to the back of my footpath at the upstream end, and that puts in 5 point whatever meters there. That's about the length of that batter slope. And on the downstream end I'll do the same thing, a measure point to point of length, and I'll go from the back of the footpath to the very downstream end of my culvert there. And now I will hit regrade pipes. Now that's lifted the culvert inverts way up, but my cover levels of my pit, which were previously set to the obvert of the pipe, are still way down low. So I can raise up those cover levels by hitting set pit details. Now that's looking a little bit better, but if I hit regrade pipes again, it tells me there's a problem in the output window, and specifically the problem is that I've got a service clash. Now because I linked in my service clashes through my service clash file, it's telling me that I'm too close to my water main there, the PW150 at chainage 17.22, which you can see right there. And it did make a suggestion there of what cover limit I could set on this pipe. Now, I could try that, or I could try changing the cover limit, or I could try changing the grade, or perhaps a combination of both. At the moment I've got a culvert that's at 0.5%, but I might try setting that to 1%, for instance, and saying I want this culvert to be just a whisker steeper, regrade pipes. I still have this problem in the output window. This time it's suggesting a cover limit of 0.74. Now I might go a little bit more than that. If I try a cover limit of, say, 0.77 or something like that and hit regrade pipes, it's pushed it down, and that's solved the invert level, the service clash problem. Again, if I hit set pit details, it updates the cover level so that they go back down to the obvert of the pipe. And there's my culvert on a 1% slope. It's still not, the locations of these head walls are still probably not right, and we won't know precisely where to place these head walls until we get the levels right, because we're going to try and match in very closely to these batter slopes, which I think are at a 1 in 4 slope from memory. And obviously the higher up the batter slope the culvert is, the shorter the culvert will need to be, and the lower it goes, the longer it needs to be. So slight changes in the grade and the levels can have an effect on where you ultimately want your head walls to go. Now I'm reasonably happy with something like that. I could push it even deeper, I suppose, if you're really trying to, if you don't want any sort of pools to form at the upstream end in this swale, you might want to get the invert right down to the bottom there, in which case I think it's about 0.8 or 0.81 should do it. Hit regrade pipes there. That's pretty close. I could possibly go a little bit further, but then I don't want to have to excavate at the downstream end. So I'll try this though as a starting point. So I've got my basic levels set now. I've got my grate levels representing the maximum water level, but they really just need to be above the top of the top of the culvert there in order for the culvert to look right in section view. Okay, so once we've got the culvert to that level, then we're going to introduce a new tool, and I don't need the network editor for that, so I'll close it down and I'll explain it back on the slide. We've just gone through all of these steps here in terms of the skip cover distance and using the grade mode of minimum grade there, set pit details, regrade pipes, we set the culvert dimensions, we set the grade RL and all that. So the next step is to extend this culvert to be an integer number of prefabricated pipe or box lengths, in this case pipe lengths, because they're normally manufactured in certain lengths of a particular length, and we use an integer number to avoid having to cut them if we can. Certainly for box culverts it's probably more important. We use it in section view to match the top of the culvert to the batter slopes as closely as possible. Obviously you can't get it super accurate, but you can get a fair way along. The important one to note there, and it catches a lot of people out including me, you have to remember to hit this little lightning bolt or regen icon on the section view, and you do need to have your culvert inverts roughly correct before you go ahead and use this. Otherwise you have to keep going back and forth until you get it right. Because again, as the invert levels change, the length of the culvert changes as well. So let's go and demonstrate this option now. It's the Extend Culvert Pipe under the Drainage More menu. So I go to Drainage More, Extend Culvert Pipe, and it brings up this little panel here. Now for pipes, in this part of the world at least, they are normally manufactured in standard unit lengths of 2.44 meters. It's possible that they go down to 1.22 in some places, but I'm going to go with 2.44 today. And I'm just going to go and use the Pick Pipe button there and pick my culvert. And it's telling me right now that if I tried 11 units of 2.44, it'd give me an overall length of 26.84. Which is slightly larger than what I've got at the moment, which is 24.623 something. Now I think I've got a general rule of thumb that I try to use when I'm designing these, and it does depend a little bit on what kind of head wall you plan to use, but I try to get the very top of my culvert, if I zoom in here, as close as I can or just to the inside or underneath the batter slope there. So I need to lop a little bit of length off both ends of my culvert here, and this, you can control which end you wish to extend with this tool and say, well, I want to extend the low chainage, which is the upstream end here, and I'm going to trial 10 pipes instead of 11, and that's going to give me a length of 24.4. I hit process and hit the lightning bolt, and that's done that. Now let's trial the high chainage end now and go with 9 links like so, and hit process and hit the lightning bolt. Now that's made a big change there, and you can see I've managed to get my culvert so that it's too far upstream. Now you could just go ahead and drag the whole thing downstream, but you can actually use this tool here to solve the problem for you. With 9 culvert links, that gives me a length of 21.96 meters. If I set that as my standard length and say I've only got one of them, I can now say, well, I want to reduce the upstream end there by about, let's try 0.9. So I'll say 21.96 minus 0.9, enter, process, lightning bolt, maybe even a little bit more. Maybe I'll go minus 0.1. So that's taken a full meter off the original length. Process, like so. Now that's got my upstream end very, very close to the batter slope, like so. And then I'll come back to the high chainage here and change the other end and say, let's add on that meter, get me back to my 21.96, and process and lightning bolt, and that's got me pretty close. Now I could possibly adjust that ever so slightly, but I think that's got me close enough, I think, in this instance, bearing in mind that the grade has changed ever so slightly because we've only been shifting the XY. We haven't been changing the invert levels, so the length has been changing, and so the grade has been changing. So I'll leave that for now as it is, and there's a little bit of housekeeping to do if I jump back into the network editor and load in my drainage model. And really all it is set pit details and regrade pipes. And that's just to re-establish my 1% grade. It has changed the invert levels ever so slightly. Hit set bit details again to get those cover levels exactly where I want them. And that looks like a pretty reasonable design. So you can see, and that's the main part of, I guess, this webinar, is to demonstrate the use of that little option under the Drainage More menu, Extend Culvert Pipe. It's this option here, to whatever standard length you use, that's going to get your drainage pipes. And you can work this on any reach in a drainage string. It doesn't have to be a single reach string like this one is. You can use that to extend any pipe reach at either end by whatever amount you want, and it's quite a handy tool. Okay, but used in conjunction with the section view, with the batter slope there, you can really get your culverts located quite precisely now. Okay, now from this point then, we don't have much more to go. We're on the home stretch now. However, we may want to, we haven't really talked about the head walls at all. Now we've got a couple of ways we can show head walls. One of them is to produce a plan plot showing a plan plot's symbol of head walls. So that one's easy enough, and I'm not going to go into a huge amount of detail here. The first thing I'm going to do though is turn the text back off on my drainage model, like so, and go ahead to the plot button there. Now again, my drainage model template's doing all this work for me. It was pre-configured with these particular PPFs. Now these PPFs are effectively the ones installed in the library of the same name, and I've just copied them into my project here, made some very minor changes to them there, nothing, mainly minor cosmetic things, nothing particularly serious there. And I've got a long section plot, again that's from the library. I'm not going to spend too much time on this, I'm just going to hit the plot button, and that's going to create a couple of new models. One of them is drainage labels, which goes and labels my culvert with the size of the culvert. There's my 3 by diameter 450. It gives me a flow arrow. It gives me the two symbols representing the head walls there, and it's labeling in bubbles the upstream and downstream head wall names. It's also in the little magenta symbol there is the actual set out point there of the culvert. Okay, so that's done a fair amount of work for us, but we can take it a little bit further, because the one downside of symbols is that they're only a 2D thing. They won't show in a section view or a perspective view. So if we want to take it just that whisker further, well, we do have some new options, and these are very new options. We've got a few different ways we could do it. We could define a trimesh in advance of a particular head wall and go and assign that through the drainage.4d, but there's an even newer option in version 12, particularly it was released in version 12 C1M, and you can find it under the drainage menu under create culvert head walls. Now I've got a screen layout file of this option, but the basic panel looks like that, but I'm going to load up a screen layout file of this just to save me some time under the layouts menu. Basically the same panel but all filled in for me, and it's very easy to fill in. You simply specify your drainage model and 2 output models. It's for every node in your model that's of type head wall something, HW something. It's going to attempt to create a trimesh fitted to the culvert associated with that head wall. And it's also going to create, in this strings model, some actual superstrings that potentially you could use as part of the road design to batter down to and use as a modifier. So I'm simply going to go ahead and run this now, and on the plan view I'm going to add the strings. And you can see the strings there. I might actually change the color of those just so that they're a little bit easier to see. I'll change them to the same grey color. Bear with me. You can see the head walls that 12D's just created for us don't really match that original symbol that the plan plot put on at all. And without creating a whole bunch of different head wall types in your drainage.4d, it's very difficult to get those symbols just right. But this tool actually looks at what culvert size and how many barrels there are and fits a head wall to it. And it doesn't just create the strings, it also creates trimeshes. I'll add the trimesh model now on in section view and also on the perspective view there. And again, I need to send my tin to the front or that model to the back. Just do that. And I can see a rather good looking couple of trimeshes there at the ends of my culvert, showing me what my head walls actually look like. Now, how does 12D get the dimensions of this? Now, bear in mind this is a very new macro, and I'm not entirely sure if it is the final product that we can expect. I would expect to see more on this macro, this create head wall trimeshes macro at the 12D conference or technical forum coming up in July, and it would be a great opportunity to provide feedback on such a new option there. But at the moment it works based on particular requirements from a particular job. This macro was developed from a particular job, and they had some hardwired head walls that they needed to model. And so it's all programmed in for those. However, you can customize it at this point, and it requires editing your drainage.4d file. And so I'll just show that briefly. I'll leave this panel off to one side up here, and I'll come back to my network editor and say, well, actually, I won't use these pit types head wall in and head wall out. I'm going to change it to another one I've got right down the bottom here, and head wall 3x450. I'll do it for that one, and I'll do it for the downstream one as well. So that both head walls, upstream and downstream, get the same type, this HW by 350. Hit set pit details. You can even actually go back to the pipe tab there and say, well, I might even change the separation here and say, well, I'm going to create a smaller head wall or a narrower head wall because I'm going to set the separation between the three barrels there to 300 instead of 450 mils. Okay, so first of all, I'll go set pit details, regrade pipes, and plot, and update the plan plot. Now, the plan plot, the symbols have disappeared now because they weren't associated with that different head wall type, the 3x450 one. So I'm still just seeing the old trimeshes there now, but I've just assigned a new pit type, and that pit type in the drainage.4d file has the parameters. And I'll run this first and then show you what it looks like. So I'll go back to editor there. I don't actually need this open anymore, I don't think. And I'll just go and rerun this panel. It's going to clean everything out and recalculate, and I suddenly get a much narrower head wall, and you can see the gap between the pipes is now smaller, and it's slightly thinner head wall too. Now these are actually the dimensions straight out of the Rockler catalogue for this particular triple cell head wall. So it's a prefabricated head wall, and we can specify those dimensions straight out of the catalogue. And we do that through the drainage.4d. If I quickly open it up, I'm not intending to turn this into a demonstration of the drainage.4d, but I can show you very quickly. In my particular one, I've got a definition right down the bottom here of my head wall 350, and it is all about these attributes here. If you go to user-defined attributes, you can define this handful of attributes here with the dimensions that you can pretty much type in straight from the Rockler catalogue or whatever catalogue you happen to be using. Now, I don't pretend to know everything about this macro yet. I've only just started learning it in the last few weeks, and I don't know exactly how every little one of these is defined precisely. But it is beginnings. Whether or not it ends up this way by the time it's released at the conference, or whether alternative ways of being able to define standard head wall dimensions get developed, I'm not sure yet. It is early days, but please, it would be a great opportunity if you are coming to the conference to talk to us at 12D. And EXDS, who also were very much responsible for developing this macro, to see and have your input and your say on it. But certainly, by all means, have a go in V12 C1M and see if you like the results of this. It is heading in the right direction, I think, as far as head walls go. And of course, they're all trimeshes. They can be used in all the ways that trimeshes are currently used. They can be exported to IFCs, in BIM models and all of that sort of thing. They can be used as part of the road design. They look great in visualizations. But effectively, it's all controlled by these dimensions that you set in the drainage.4d file. But that's just done the head walls. I could take my drainage model off the view, in fact, and run another option under strings, trimesh, create trimesh from 12D objects, and create my drainage culverts as trimeshes as well. Again, I've got a layout file that's going to run this option, generate trimeshes from 12D objects, and again, it's very simple. You just specify your drainage model and an output model and whether or not you want to copy the pit and pipe attributes. Go ahead and run that, and that will go and convert your nodes and links to trimeshes. In this case, my nodes have 0 size, and that's the way I normally model culvert head walls on the drainage string, and I then assign a symbol or a trimesh head wall to model the head wall. So I've only got the links in here, and that's in a model called DRTM. Again, I'll send that to the back of the view. And that is an alternative, and again, that's just a trimesh version of this. The trimeshes are arguably a little bit nicer than the drainage strings. The end caps of the pipes are closed off and things like that. But all the attributes are there as well. You can do an F8 on the individual trimesh barrel there, and you can see all the attributes from the original drainage pipe are there. Okay, so I did have a couple of extra slides there showing you, yes, by all means, there's lots of good example plot parameter files in the library, and use the plot button on the network editor to quickly update your plots. So I glossed over that one pretty quickly. And there's just a slide there going through the details of where you can find those 2 options for generating the trimeshes, and an example picture on the right as well. Again, it's a very new option, this create headwall trimeshes. I'd love to see you and talk to you about this new option at the technical forum in Brisbane in July. Other than that, though, I think I'm just about on time now, so I would like to wrap things up and open the webinar up to any questions we may have had while I've been gas bagging.
Thanks,
Over
Owen.
to you, Lisa.
Thanks. We do have a few questions here, actually, Owen. I think the first 2 might be sort of related, so I might read them both out, and I'll let you sort of decide whether to answer them separately or together. So Jody in Sydney has asked, can 12D model skewed culverts? And Gordon in Brisbane has said, when there are multiple pipes on a skewed culvert, can the pipes be offset longitudinally to match the skew?
Yeah, they are related, those questions. The answer, as far as the drainage string is concerned itself, the multiple barrels within the one drainage string can't be offset, which is effectively what I mean by skew, I guess, because normally each barrel has the same overall length, but they're offset from each other. What you can do, however, so I guess the answer is yes to a point or not quite, depending on whether you're being a pessimist or an optimist. But if I were to just do a quick example here and imagine that this was actually a skew head wall, one thing you can do is on the pit setout tab, you can set the head walls on whatever angle relative to the culvert you want, and in this case I'll use the manual mode there, and I might say, well, actually that's coming in at a bearing of let's say 250, and I'll do the same thing on the downstream side, manual 250, set pit details, and I'll probably need to regenerate that head wall panel, which I just got rid of. One moment. Layouts, layout inputs. This one, I'll rerun that process. Oh, got the network editor open, not a good demo, Owen. Retry. There we go. and my head walls now have that. Now you can set the head walls on whatever angle you like, and that would be what a typical skew head wall looks like. If I were to take the drainage model off the view momentarily, and I've got the drainage plan plot underneath. Now the drainage plan plot is individual superstring pipes there, so you can certainly translate sort of this upper one a little bit to the left and the lower one a bit to the right, so it ties back in with these rotated head walls. That is probably the only way I could recommend a skew culvert. Obviously the head wall needs to be a different shape as well. It gets quite complicated, skew head walls and skew culverts, and I don't think they tend to like making them much anymore, not as much as they did in the past. Certainly they much prefer non-skewed culverts and non-skewed head walls because it suddenly becomes a much more complicated problem. So yes, the wing wall angles and all of that, you need different head walls for that as well. So in answer to your question, you can go some of the way, but perhaps not all of the way with the tools that I've shown you in this webinar.
Okay, great. Michael in Brisbane has said, can you output quantities of concrete volumes if using cast in situ culverts and base slabs?
Well, once you've got them converted to trimeshes, I suppose in theory, yes, if these trimeshes yield a volume, you'll be able to do it that way. I'm suspecting this question might be related to or comparing it with the TMR culvert macro, which I know is quite famous for, or the culvert program I should say, which is quite famous for being able to do that. We are heading in the direction of coming up with generic culvert and head wall creators that create trimeshes rather than individual strings, and we're trying to do it generic so that it will adopt standards more broadly than just the Traffic and Main Roads Department of Queensland. So our direction, I think we're heading at 12D, is to do everything with trimeshes. And of course, trimeshes, if they're built correctly, they do yield a volume, and you will be able to sum up quantities that way for both the culverts and the head walls, I should add, once they're all trimeshes. So perhaps that's the best answer.
Thanks. And finally, Ben in Melbourne would like to know, can you have a collection of culverts in a drainage model where some have the flow direction same as and some opposite to the string direction?
Yes, you can, and that's an interesting question. It's something that I discovered fairly recently, actually, that some people have a convention for their culvert long sections, so that when they show the culvert here, they want the left-hand side of the road always to be on the left, so it's relative to the road direction. In this case, most stormwater designers always have their stormwater pipes falling from left to right, but these people were wanting a convention where it depended on the road direction, so that when they look at their culvert long sections, which is typically also a road cross section, they want the left-hand side of the road on the left and the right-hand side of the road on the right. Now in this example, it just so happens that I've got on my drainage profile, the right-hand side of my road is on the left and the left-hand side of my road is on the right. So some people get very confused by that. So in truth, you actually can have a mix where some culverts have their flow direction set same as the string direction, and some culverts have their flow direction set opposite to the string direction. And you'll see when they plot out in the long section plot that some will fall from left to right and some will fall from right to left. I didn't do that in this instance mainly because this brand new culvert head wall macro only supported the head walls where the flow direction was same as string direction. So I was quite careful in that case, but that's just a minor issue. That's a teething problem, I suppose, with this macro that we will get addressed. It's quite embarrassing in a demo if your head walls face the wrong way, so I was careful to avoid that. You know, you can imagine that throughout a job you could quite easily have a mix of different flow directions if that was the convention you wanted, of always keeping the road side on the left on your long sections of your culverts. So yes, we do support that. The only caveats of having mixed flow directions is you can't join two drainage strings together that have different flow directions set. Other than that, it's perfectly fine.
Well, thank you, Owen, and thanks everyone for those great questions. We've got some great training courses coming up in Brisbane, Melbourne and Perth. We've got a handout on the webinar outlining what's in some of those, and you can register through the training page of the website, contact us by email, or indicate in your post-webinar survey that you'd like to be contacted about training. And don't forget our 12D technical forum that Owen was mentioning earlier. It's on again in Brisbane this July, and it's going to be a pretty huge event, so jump online and register for that if you haven't already. The recording of this webinar will be available in coming days through our website and our YouTube channel. Our next two training webinars are Drainage and Object 3D Clash Detection on the 26th of June and Dealing with Assets that Don't Fit into ADAC on the 15th of August. In the meantime, we've got some great industry solutions topics happening, so feel free to sign up for those and many more through our website. We'll keep you posted on all of that through email and social media if you're subscribed, and if you need to contact us in the meantime, our details are on the screen now. That concludes our presentation for today. Thank you all for attending, and we hope to see you at future webinars.